In this video, I introduce a learning affordance for direct perception in autonomous driving. There exists two popular strategies for training autonomous driving model. One is the mediated perception method. Second is a behavior reflex approach. The first method processes the entire procedure to multiple stages, such as perception, prediction, planning, and control. We solve each stage separately, and then we combine the results from each stage to get the final result for the original problem. The behavior reflex method also is the end-to-end method that directly maps an input image to a driving decision. The method we are introducing now is called the direct perception approach. That is in between the two methods and maps the input image to perception indicators to find the important features related to the driving behavior and enable the controller to predict the driving decision based on these indicators. Let's recall the NVIDIA ARNet self-driving model. We have demonstrated that after the convolutional neural network module, we found which part in the input image is important for the machine driver. For example, if we road with this lane markers, then now we can find this lane markers and the traffic are important to the machine driver. If a road without the lane markers, then there's a car parked along the street are important for the machine driver. Right now, the direct perception method is just like we insert one stage into the end-to-end model to explicitly find the preceding class are important for the self-driving model. If we simulate the model on the simulator, then now we have from the screen card, we have this lane markers, and we show what's the angle between the car heading and the tangential of the road. And then we can see this self-driving car and the proceeding cars here. If we just do the road following, we just clear the preceding cars. If we do the lane changing, we clear all the preceding cars. And then now we define certain indicators. For example, if we simulate the model on the Torx simulator, then now we use this convolutional neural network to use this screen card as an input to the network to predict the certain indicators. The controller, based on these 13 indicators to predict the driving decision. And then I use this driving decision, the simulator drive the car. However, if we in the real world, for example, on the KITTI training dataset, most of the roads have no road markers. However, because this the training dataset has a 3D point cloud, so we can use the point cloud easily to determine the distance between the self-driving car to the nearby cars. And then now we just split the input image into three regions. One is the inland region, this is the right region, this is the left region. And then similarly, we determine what's the important indicators. Based on these indicators, the controller predicts the driving decision in a similar way. Follow this procedure. Because right now for the self-driving, it's much simpler than the robot because we only care the steering angle and the velocity. So we just use this, the distance, vehicle distance from to the central line and determine what's the steering command to driving car along the road. And also we use this distance from the self-driving car to the preceding cars to determine what's a proper speed. So right now, the direct perception method just insert one stage to the end-to-end model to explicitly define 13 indicators. And then the controller, based on this 13 indicators, to predict the driving decision. For more details, please check with this reference. Thank you. Bye.